Okay, so here we are. The pacing guide is, we're down here to week 15, right? So we've got Monday's material, which is what we'll cover today. And you can see what we're doing Tuesday and Thursday. But then, yeah, week 16, our actual last day of new material is going to be probably Thursday. I'll probably tag on this last topic, which is solving a system of nonlinear equations. I'll probably put that in here, and then we'll have a review day for the test, exam 5 on Monday, and then probably open up the test. Oh, probably be open, we'll say Tuesday at Tuesday, May 5th to Tuesday, May 6th. That way you've got a break on the 7th because our final in this class is going to be on Alex from May 8th at midnight, starting at midnight to, oh, here we go. This probably look better. So our final is going to be May 8th, starting at midnight to May 11th at 11:59. So you'll have the 8th, 9th, 10th, and 11th to do the final for this class. So the final is dealing just kind of it's a cumulative final, and it's actually a placement test for college algebra. So there's 32 questions. Let me write this down. I don't know, oh, there it is. Okay. Okay, so let's go ahead and get everything written down that I had mentioned. So exam 5, the tentative date is going to be May, it's almost May. I wish I could switch my calendar over. What is it, May 5th to May 6th? So May 5th, again at 8 a.m. to May 6th at, I'm going to go ahead and make this 11:59 p.m. just so you've got a little over, yeah, a little over 12 hours there to do it. Again, we can change on that, but the reason I made it that is the final exam is open from May 8th at midnight. So 12 a.m. to switched up my key binding. So we're going to see if this works better. Although, there it is. Okay. To May 11th at 11:59. Okay, so some information about the final is it is 32 questions. It's on Alex. So you have to finish it in one sitting. And you have 3 hours. Alex, 3-hour time. Yeah, something like that. So the other important thing is scratch work. So this is going to be 32 questions, and yeah, you've got 3 hours to complete it. But again, Alex marks it either completely correct or completely wrong, right? So again, each question's worth 4 points. So that means that scratch work will be due, or yeah, so scratch work you turn in on Blackboard, so just like normal. And I haven't really been too strict about when, but for the final scratch work will need to be turned in on Blackboard, 30 minutes max after you finish the exam. Right, so if you finish the final Monday, May 8th at 9 in the morning, you need to submit the scratch work 30 minutes after that. So it's just to ensure that you did the scratch work when the test was going on. Are there any questions over that one right here? Do you guys think you'll need more time to submit the scratch work, like an hour? Would that be better or does 30 minutes seem fair? know if anyone's in the chat. Let me open it up.
I'm good.
Okay. All right. So that'll be the plan then for the final. I'm going to ask around here this week to the other instructors who've taught this course and try to get like a study guide out to you. Usually the old professors or instructors who've taught this have like a nice, guide. But again, we don't make the final, so I'm not quite sure what's on it. So I think that will be best. So move this down real quick. Okay. Move the chat down here. Okay. Yeah, so the last thing I wanted to add about this is review, hopefully by this Friday. I'll email it out to everybody. I don't know if I'll make an answer key. If the answer key isn't provided, I don't know if I will do that. I'll try to. It depends on my time and everything like that. But again, it's just a cumulative view. So I would look at old exams would be a good way to like start. A good way to start is just look at the old exams. And the old daily works, because again, all the daily works are, I put those on the exam. Okay. The other thing is you got a email about the STPE. I think that's the letters. So this is an evaluation. I think you have all week to complete. So you don't have to, but it would be good. It's good feedback for me. Um, so just complete if you can. It's good feedback, so I know that if this happens, if this quarantine pushes on to next semester, you guys can let me know what I did good about online and what I did bad. so it's evals about me. Again, I won't see them till after grades are posted, and I think grades. I'm just guessing. Um, Grades are due probably like the Monday after everything. So I'm guessing May 18th. So this is for all your classes. I'm just guessing. It might be due sooner, but I would imagine around that time. So, you should know by then. Are there any questions before we continue? Okay. Are there any questions just over any of the stuff that we've covered so far? Anything from the daily works? Remember, I'll have office hours tomorrow at 6 p.m. So if you'd like to ask then, from 6 to 7. So you can always ask then if you'd like. I don't know. I don't know if I'm teaching college algebra next semester. I don't think I am. College algebra didn't line up with the classes I'm taking. So I signed up for pre-calc and business calc. Um, I think I might have signed, no, I don't even think I signed up for beginning or intermediate algebra. I'll let you know though, because I think college algebra was like my third choice just because it was kind of close to my other classes. But I'll let you know. Any of the instructors who teach it are good. No, I'm not just saying that. They all seem pretty good instructors. I haven't heard anything bad. So again, my office hours are, there it is. Okay, so office hours, again, are from 6 p.m. to 7 p.m. Tuesdays and Thursdays. So if you have questions, you can come to those. If not, email me. We can schedule the time outside of that if you'd like. Okay, so if there are no more questions, we'll move on to today's material. So as you can see up here, we're doing sections 8.6 and 8.7, like the second part of that. Really, there's only one thing we're talking about in 8.6, and then we'll deal with 8.7 later, like tomorrow as well. So, all right, so here we go. We have the change of base. So we've kind of talked about the irrational number e before, but what we're going to talk about now is change of base. And the reason the change of base is so important is, let's say we were wanting to evaluate log base 2 of 4, right? If we wanted to evaluate that, well, there's some things we can do, right? Remember that you can rewrite log base 2 of 4. Again, it's probably good to put this in parentheses, right? To know that this is how you can write it. Right, know that you can evaluate this by just using the logarithm properties, which we talked about on Thursday. So go back and check out that video. Good math joke in there. So remember that you can rewrite 4, might even be good to write 4 in a different color. Let's do green. Remember that 2 or 4 can be written as 2 squared. And the reason that that is so nice is because now we've got a matching base of our logarithm and a matching base of our exponent, right? So they undo each other, and this just equals 2, right? Because these undo each other, right? So you can evaluate these logarithms without actually having to use a calculator, right? Another way that you could look at it, let's do like log base, let's go 3 of 1 over 27, right? Again, the question, right, is what is this going to equal? Well, here you can just convert it to an exponent form, right? You can go using what we know about exponents, we can say, well, the question is 1 over 27 is going to be equal to 3 to the what power, right? Again, that's just using the equivalence of logarithms and exponents, right? So again, you can evaluate these by just using the properties that we know. Okay, so the question is, what does this equal? We'll be thinking of like what, in pin mode? There we go. Be thinking of what, how you get a fraction from an exponent. Anyone know while I pick my color here? Right, because remember that this here is a fraction, right? So we know that the exponent here that we're looking for is going to be negative, right? So you can rewrite this without it being an exponent or without it being a fraction. And so you get 27 to the negative 1 power, right? And we got to figure out what this is. So then change this to match the base here. So 3 to the 3rd power to the negative 1. Again, now you multiply these together. So 3 to the negative 3rd power is equal to 3. Right, so then that means that this is actually equal to negative 3, is what all of that work there was showing. Do we want to see another example of these problems? Just evaluating logarithms. Okay. Okay, these are 2 different methods. Again, we talked about this, I think, on Tuesday. It was either Tuesday or Monday's lesson. So these are 2 different methods. Personally, I like this method. This method here, I used a question mark. You could use a variable x, but I think this one is better. So let's do another one with a fractional exponent. Okay, let's do, and this is tying into this calculator image. So, there is a purpose for all these examples to kind of show you why we're doing these. Okay, so let's do log base of, we did 3, let's do 7, 1 over 49. Right, so now we want to evaluate this. Again, we can get a matching base, right? This is going to be similar to method A. So these are 2 different methods that we have. I'm going to switch over and move this over a little bit. So this is 2 methods that you can use. Personally, method A I think is better, but it's really just whatever you prefer. Okay, so again, it's log base 7 of 1 over 49. Well, we want a matching base of 7 to basically cancel out with the logarithms, right? So that means, right, how can I rewrite my fraction here, right, as not a fraction? Well, remember that you can write it as, okay, well let's write it like this. We know that 49 is 7 times 7, right? So we've got 7 squared. Well, we're close, but notice it's a fraction, right? We can't do anything, but we can rewrite this 1 over 7 squared as 7 to the negative 2 power, right? Because this property here that goes from, let me use green or orange, from here to here, this is saying that x to the negative m power is equal to 1 over x to the m. So that right there is a pretty important exponent property. One thing that would be nice to have, again, you can't use your book on most tests, but again, this is online, so there's no way of stopping you from using your notes. You know, it's important, these exponent rules. So exponent rules, which if you Google exponent rules, you'll see them all. Um, you know, just to show you exponent rules, right? Googling exponent rules will give you these, which we've used quite a bit. And the one that we're using is this one right here, the negative exponent rule. So that's a really important thing to know, because it would help you solve this type of problem without doing, well, even here you use it as well. Okay, so we're all the way down here. And our final step is we found that it has a matching base, right? Your base here of 7 and your exponent base of 7. So these undo each other and you're left with -2. And that is how you would evaluate that. Are there any questions about these types of problems? Again, it's using logarithm rules or properties. It's probably properties. So another important thing to be aware of is logarithm rules, which logarithms do rule. I like them, but yeah, know those. Like, you know, be comfortable with those. Maybe look at them now, and then, you know, think, well, do I know what those are? Okay, so anyway, the whole reason that we're going to talk about change of base is, what if we had something like, so the question is, why is the change of base this is all just one thing important, right? Because we've looked at evaluating logs like this. Well, what if we had log base 3 of 7, right? Well, notice there's no way that we can change 3, or excuse me, there's way we can change 7 to have a matching base here, right? So, well, what if we did this, right? Well, what if we said, well, what if we convert to an exponent form? Well, here we've got this, right? If we were to switch over to exponent form, right? Because this is in logarithmic form, that this would give us here. It may be good to show why we're going through, or you know, what it looks like to go through them, right? So if I just said this was x, right? Well, what is x going to be when I evaluate this? Well, you know, if you wanted to go to exponential form, you can exponentiate, right? Where you raise these up to this power. I think this was the very first thing that we did, was going in between these two forms. So this would give you 7 is equal to 3 to the x, right? Well, there is no integer that I can think of that would give you this, right? The question is, how many times do you multiply 3 by itself to give you 7? Well, I don't know, right? Like, I can't figure that out. So that is why change of base is important. We're going to figure out, we're going to use the change o base cob to find x, right? Again, what we did right here was on lecture, I'm looking up at the calendar here. What is today? This is 27th? It would have been 23rd, it would have been, I think, there. It would either been there or 17, but I'm pretty sure it was the 20th of April. Okay, well, what we're going to do here is we're going to use a change of base. And basically, if you have a scientific calculator, it might look something like this, right? And even I have a calculator on my computer, and you probably have one on Alex too, that looks something like this, right? They're both scientific calculators. Now notice that we have a log button, Well, the log button is only with a base of 10. So that means with a calculator, I could use this button here, the log button, but the log button only evaluates things with a base of 10, right? So I could put in log base 10 of 3. Again, if we wanted to know what this was saying, it would be saying, well, right, well, what x value is going to give us that? Well, if we were to go over here, we could evaluate it. It would be 10, and then you hit log. It would be 1, hold the phone. That's not what we want. It's I'm not very good at using scientific calculators. Oops. Right, so you pick the number that's going in there, so it'd be 3, log 10. Right, so it'd be 0.4771 and so on and so forth. So here, x would be approximately 0.77, right? And then that's using the calculator. But notice that this question here, we have log base 3, right? And we don't know how to do that. There is no button on this calculator that allows us to do that. We do have a natural log button, so we'll keep that in mind too. Remember that natural log is log base e of something, right? So log base e or log base 10 are the two things scientific calculators have. Even this one here has the natural log one. So we're going to learn how to use change of base to solve these types of problems that aren't normally solved on calculators, right? These types of problems you have to use a calculator to solve. Okay, so we have the change of base formula. Now the change of base formula is saying if a and b are positive real numbers, right? A and b are not 1. You can't evaluate log of 1. That's not a valid thing. Again, if you wanted to know why, right? If I wanted to do like log base a of, oh, it says that. Like, why can't that be 1? It's you know, if you were to convert this to the exponential form, it would be saying what power of, right? Because that would always be 1 is what I'm getting at there, right? Going in between these, it's probably easier to see why that can't be 1, because that will always be 1 basically. If this number, oops, if this number here, b or a is 1. Okay. Okay, so here's our change of base form. It's saying log base b of x is log base a of x over log base a of b. So it means no matter what base you have, for example, if I wanted to write, oh, pin mode's off. I wanted to write log base, what was our example up here? Log base 3 of 7, right? If I wanted to solve this, I could change it to, let's say, a base of 10. So converting it to a base of 10, using our formula would be log base 10 of 7 is divided by log base 10 of 3. And we could plug that into the calculator and that would tell us what that equals, right? These two are the same. Probably should be using an equal sign here. Oops. Right, these are the same. And now we can evaluate it using our change of base. Now, I wasn't going to show it, but I think the proof of this, see if I can recall it, like proving why this is true. I've worked it through once. So if m is equal to log base b of x, then you can write this in exponential form. So in exponential form, it is b to the m is equal to x, right? And then, oh, I might actually have to refer back to, I don't think I have it open. Okay, if you're interested in the proof for this, let me know, and I can upload a video of why this is true. But for now, we'll use the formula and figure out what this equals. Okay, so we have a bunch of examples here. Let's go ahead and finish this example that we started up here, right? Where how would you type this into a calculator? Well, we're doing a base of 10, which means I will be using this button, the log button, right? Because log on the calculator is log base 10 of whatever's in the inside. So you would do, oh gosh, always forget. You do the thing first, so 7, so log base 10 of 7 is this, and you're going to divide it by 3, log base 10 of 3. And so again, if I wanted to go, let's go to 3 decimal places, but that would be 0, or yeah, 0, oh gosh, 0.477, right? So if I wanted to go to 3 decimal places, that is what that would equal. Okay, let's do a couple of examples and we'll see how we feel about this. Again, you want to use the change of base because we can type it into a calculator is the reason we want to do that. Okay, so 2 examples here. They're both having us change it into 2 different bases. So the first one is you use the change of base formula to evaluate log base 4 of 80 by using base 10. So here we round to 3 decimal places. Okay, so we want to evaluate log base 4 of 80, right? Well, we're going to use our change of base, and notice that what it wants us to do is change it to a base of 10, right? So a log base of 10 means that we're going to use the log or log base 10, right? These mean the same thing. Okay, so using our change of base formula, you can always think that the base of this logarithm is the small 4. That's going to be your basement of your fraction, right? So the big number is going to stay up top like the attic, so log base of 80, and then the base of your logarithm is your basement, so log base of 4, right? And so now we would plug this in and see what it is equal to. So go to your calculator, clear everything out, and we want to do log of 80. So here's log of 80, and you're going to divide log of 4. And so to 3 decimal places, right, that means we're going to round to here, right? We've got 0, so we're not going to round up, we're going to round down. So it's 0.602. And that would be how to do the base of 10 for that. Any questions for log base 10? Okay, let's go to the second example. All right, so this one's a little bit different. This one wants a base of e. So with a base of e, we're going to be using the natural log function. So the ln or the actual base is log base e. Now these two are really common. So it will be asking you to do the change of base for either one of these, because both of these options are on a scientific calculator. All right, so again, we're going to do log base 4 of 80, right? So here we'll do natural log of 80 divided by natural log of 4, right? Remember that the base of the logarithm here is your basement of the fraction, is how I like to remember it. So the small number goes in the denominator. So it'll be really similar to the other one. Find my mouse. Where we've got the natural log of 80 divided by natural log of 4. So in this base, we're going to have 1.386, right? Because we want to go to 3 decimal places. So depending on the base that you use, you know, you'll get a different answer there. But again, log base 10 and log base e are the most common ones because they'll show up on your calculators. Are there questions? Okay. We'll go on.
You said we have to use a calculator to do these ones, or?
Yeah. So we want to use a calculator because you wouldn't be able to do methods A or B. So a couple classes ago, we solved a couple using this method where you were basically wanting to match. Let's go to this method where you wanted to match the bases, right? Log base 7 and then a base of 7 for the exponent. That undid it, so you had this. But for this example, we're not able to do that, right?
So
These are
do
special.
you think the calculators that are in the phones, like the default ones, would that be able to do these,
I think so. Let me look
or do you know
here.
of a good like calculator app to download?
Any scientific calculator, it should did.
Okay.
We can get in there. Okay, what was I gonna do? Yeah, so I think any calculator on your phone will have the logarithm because most phones have a scientific. Yeah, so if you look at my phone, I don't know, right? That even my base one has the natural log and the log function. So this is
I think
having.
mine has it too. I just wasn't sure.
Yeah, it's the common one to use for these. Let me again. So that's why I use it because almost all phones and the one on Alex, the calculator will be given on Alex. It will, thank you, will have these two functions, log base e and log base L of n. So I'm wondering why we got two different answers here for that one. Let me check something real quick. Was it 4? Yeah. Okay, let me. Okay. All right. So here's what the daily work would ask for. And I was going to pull up the daily work for you, like on Alex to show, but it gives you a calculator. So in these problems, Alex will have a little calculator button out to the side. So if you don't have your phone, handy or something, Alex will give you a calculator for this problem. Okay, so we're going to use the change of base formula to compute log base 7 of 5. Okay, so for this problem, I'm going to use log base of 10. The log base of 10 is the one I usually go to. I'm wondering why we got a different solution for those because it shouldn't matter the ones that we type in. So I'm curious of why it gave me two different ones.
Depending on the calculator I used, depended on the answer I got also.
Yeah, it should give you the same one. So I don't know why it's not. Yeah, I assumed that. Oh gosh, I hit the wrong button. Did she join here? Okay, she hasn't joined yet. Okay. Yeah, because it's giving you 1.38. Or base E. I will have to come back to that, but it shouldn't. I don't know if I'm just typing it in wrong here. Okay. We'll come back to it. It shouldn't matter when you type it in. So I'm not sure why it's given us two different answers here. So I will come back to that. But we'll continue on. So again, the log base is, or the change of base formula is telling us that we're going to use log base b of x, right? That's going to be log base of whatever base we want to choose of x divided by log base of whatever base of b, right? So there's a log base formula here. And we're going to round to the nearest thousandths, which is the 3 decimal places. Okay, So log base 7 of 5. Again, it's always good to put parentheses around there so you have it. I'm going to use log base of 10. So we got log base of 5 divided by log base of 7, right? These have matching bases, right? This is log base 10 of 5, log base 10 of 7. Oops, not 70. Okay, so we type this in. Not fully confident in this calculator that I'm using. I normally use mine. If you've got a fancy calculator, it should actually, you could do a change. You don't have to do change of base if you have a fancy calculator, but you're not required to have one. So, okay, did everyone get this? A log of 5 divided by log of 7, 0.845. I don't know where my calculator's at, my fancy one. Was that what we got here? 0.845, I think is what I had. Again, we choose either the log base 10 because it's in the calculator, or we could choose the natural log. Right? These are our two most common ones, and again, it bugs me that it came out different because even our formula, it should be the same. So I think I don't know. I think it's something I'm typing in. I don't know where my calculator's at, or I would look. Did anyone try this one here?
I got different answers using the natural.
The other one? Yeah, it's still higher. I don't know. Let me look. My calculator is here. Same. If you've got one that is a little more expensive, it does a little more things. What am I at? Log base of 5. 2. Yeah, okay. So look, I'm not sure what I'm doing wrong on the computer, but the natural log should give you the same one. So I don't know what's going on. Let's try this because it shouldn't matter. You should be able to choose log or natural log. I wonder if it's because we're not trapping all of our values, so it's losing some of its values here. So if I go natural log, oh, I did it again. I don't like these calculators. While I'm doing this, I had to take a test, like a math test, when I wanted to teach high school. And the other class I was in let me use my fancy calculator I just showed you. But the one, and I didn't pass it. I missed it by 1 point. So I went in to retake the test and they wouldn't let me use it. So I had to use the calculator like this on the computer. And it was so frustrating. So I did it again. Okay, let me focus. So there we are. And then we would do natural log divided by the natural log of 4. So yeah, it's still, again, I don't know if I'm typing it incorrectly. Okay, well, if it's not doing that, we could express it as this. What if we did, because whenever you are dividing these logarithms, again, it's the way this calculator is reading it, right? That you should be able to do the log or natural log -2. Oops, let me clear this. Oh my goodness, okay. Thought I did enough prepping for this invalid one. Okay, okay. I'm not sure. I'm gonna have to come back to it because I can get it on my calculator, but for some reason this one is losing losing some of the values. And I'm not sure how to not get it to, you know, because this just goes on forever, right? It's an irrational number. But I'm losing some values here. Try one more thing. Yeah, it's still giving me, oh, there it is. We got it. No, we're close. What in the goodness heck? Okay, so, man, let me try this again. All right, hopefully you will not have as frustrating time doing these. Let me do this, match it like that. I'm gonna use a lot of parentheses to trap these values. I don't know if we're losing any you know, important information here. Log of 7. 8.27. Is that what we got on the other one? 8.27. I think I might know what it is. I apologize for not working this closer. I sat here and I got the size of this calculator down, so I enjoyed working with it. Okay, so I think I know what it is. So this is logarithm of that divided by. So I think if you put parentheses around it, it should, oh gosh, it should trap. I call it trap the values. Really, you just don't want to lose any of the digits here. Okay, so that is what it is. The calculator is just being really frustrating. Right. So a good tip is when you type this in with your change of base, especially if you're using a scientific calculator like the one you have on your phone or computer, which means the answers up top I need to adjust. You want to put them in parentheses, right? So if I wanted to type, let's say, this one in to the calculator, you'd want to do parentheses, the natural log of 5, close parentheses. That's trapping all the values in there. And then when you divide it, you do the same thing. And you do the same thing for the logarithm. So really what you're doing is you're losing significant figures whenever you leave off a parenthesis. Are there any questions over what was going on there? Would we like to see another example so you guys can try with you know, try calculating one?
Yes, please.
Okay. Again, I apologize that that did the thing that it did. So yeah, let's look at another example. All right. Yeah, using calculators is frustrating because half the battle is just doing it correctly. So let's make sure we don't do one that we can evaluate. Let's do log base of 8 of 3. Yeah. Okay, so again, choose the base that you would like to use. It would either be log base 10 or log base E, right, natural log, and see what you can get, right? So you're really two options here. I mean, you could choose any base if you had a calculator that could do it. So be typing that in. I'm gonna write this on here. So you've got log base 10 of 3 divided by log base 10 of 8. That's the change of base formula, which is log of 3 divided by log of 8, right? Just a way to rewrite it. Now here, log base E, I would leave out this intermediate step that I'm writing in. I just want you to be familiar with why we use natural log, you know, and just a regular log. They're just two different ways of saying the same thing. Okay, so when you think you have a value, let me know, or actually let me type it in first, and we'll make sure that we match here. So using a calculator like this, I'm gonna put a parenthesis. I'm gonna do the first one, so, oh, I did it again. Okay, so parenthesis, we're gonna do log of 3, close parenthesis, because we're gonna trap all those little decimals in there. We're gonna divide it by log of 8. And did we get, 0.528. Just to see if I got the same thing with the other one. Was it okay, 528. I think I said the wrong number when I said it out loud. Okay, let's see if we get the same thing with the natural log using these parentheses. Again, it's how the calculator is evaluating it, is what gave me trouble. I don't know if you're having this similar trouble, but that is what happened to me. Okay, so parenthesis, we want to divide by 8. So 8, natural log, close it, equal to 0.258. Anyone have any trouble with theirs? Everyone good? Did we also get 0.528? Again, it's important to use the parentheses. You probably could even use them like this if you wanted to have a parenthesis on the outside. Right, 2 parentheses. This is probably overkill, but it would definitely get what you want, So have a parenthesis on the outside that's going to stay there until you type in the very last one here. So we're doing log base 10. So that would probably be the best method there to use, is a bunch of parentheses. And when I say a bunch, it doesn't mean just a ton, like unnecessary ones, but let me write this here real quick. So again, if you wanted to do this one, have a parenthesis on the outside, right? This is everything inside that you're evaluating. So then you'd have a natural log of 3 divided by natural log of 8. I guess you could have a parenthesis on that one. Did anyone get the same thing that I got?
I did.
You did? Okay. Again, just be very careful with it. If I went back up here, we'd actually have to reevaluate these because these numbers are different. So let's do that. Go ahead and try doing this one. We're not really behind at the moment, so if you're worried of this class running over, I mean, it probably will because I'm bad about keeping under time, but we only have like one example next. It's just a bunch of the same example. So this is good that we have practice. So try typing this in. I will do the same. All right, so we'll get the same number. Frustrating. All right, so what are we, 80 log. We're going to divide that by 4 log, close the parenthesis. Is that what you got? 3.6? I don't think so. I think I might need to put an extra parenthesis in there.
What I got.
Yeah, that's what you got. Anyone else get anything different? Okay, so that's really what the trick is. I wouldn't even call it a trick. I would just say to write this, what was it again, Shelly? 3.16? I guess to 3 decimal places would be 1 then, right? Because we went to 3 decimal places. All right, if you were going to type this into your calculator, put these one big parenthesis, and then what you would need to do is have log base of 80, like that, divided by log base of 4. And that keeps all of your important values, and you can get the value that the calculated value. Okay, so doing the same thing down here, you'll get 3.161. Okay, any questions over to the change of base formula before we move on to section 8.7? Again, it's a really handy tool to have because, a lot of these things you can't evaluate by this trick up here. So the log base or the change of base formula allows you to do that. Okay, and again, doesn't matter if you use log base 10 or natural log, both will work, as long as you type it in your calculator correctly. Okay, so the last thing we're going to talk about today is solving logarithmic equations. This is section 8.7. So here are your steps. You want to isolate the logarithm on one side of the equation. Again, this means combine to a single logarithm. So basically, you want one logarithm on one side of the equation for these problems. And then you can express it in exponential form and solve the resulting equation. And then check to make sure that it works, you know, that you actually get something in the domain. This means
He's upstairs.
this step right here is saying you can't have a negative underneath here. So this is can't be negative. Right, so be aware of that. Be aware that that you can't have a negative underneath the logarithm. That is what step 5 is talking about. Okay, so let's work at solving these and see what we need to do. Okay, so we're going to use, to do these examples here, you want to use these ideas, these two properties, logarithmic properties. Now, the first one, or let's do a star. The first one is saying that if you have log, let's just do b to b to the third power, you know, just a nice example like that, that this is equal to 3, right? When you have base, a matching base for your logarithm, matching base for your exponent, you can basically undo the logarithm. The other one is saying if you had b raised to log base b of, let's say, 4, right, that these undo each other and you just get 4. Right, so we're going to use these two properties to help solve these equations here. The idea of undoing logarithms. Okay, we'll move down here. Let's try this example here. So step 1 is already done. We have the logarithm by itself. What we need to do now is undo the logarithm. Right, so we have the logarithm alone on one side of the equation, which is what we need, and we want to be able to undo the logarithm. So that means we need to find the base to exponentiate it to. Right, so be thinking, like, what do I need to have my base here? What base do I need? Well, it would be a base of 3. Because I want to undo the logarithm, which has a base of 3. So you exponentiate on both sides, and this becomes 2x plus 5, and this is 3 to the first power, or just 3. Right? Okay, so this is 3, 2x plus 5. So now we solve for x, just like we would do normally. So subtract 5 on both sides. This is 2x is equal to negative 2. That means divide both sides by 2. And x is equal to negative 1. Right, so last step, division, would give us x is equal to negative 2. Or excuse me, x is equal to negative 1. Okay, before we do that, we have to make sure that we don't have a negative underneath the logarithm, right? This it can't be negative, right? But oh, wait a second, but we have a negative 1. Well, let's plug it in and see what happens. So 2 times negative 1 plus 5, right? Well, that's going to be log base 3 of negative 2 plus 5. And this is going to give us 3. Log base 3 of 3 is 1. And so everything works out. We get the same thing. So by checking this, we find out that x does equal negative 1. Right, because we've just proven the left side equals the right side, which is what we wanted. Any questions? Okay, let's look at another example of this. This one here has a log base of 6 and it's equal to 2. Okay, so to solve this one, again, we need to be thinking of how can you undo your logarithm, right? And we can exponentiate, right? It's the idea of going, you want to put in exponential form, right? And in exponential form, that means we can exponentiate on both sides, right? So again, we've got an equal sign here. And to do that, we match the bases, right? So we've got a base of 6 here, base of 6 there. And we're basically raising this up, so 2. And then we've got log base 6 of 5x minus 4. So we raise everything up with a base of 6 like that. All right, so log base 6 undoes the logarithm here. So we have 5x minus 4. And here, 6 squared is going to be 36. Continuing on, we add 4 on both sides. So we get 5x is equal to 40. So x is equal to 8. Again, before we can finish this problem, we have to make sure that what we have, the solution works, right? So that means we need to plug in this value and make sure it equals to 2, or all right, to make sure that 8 is a value that is. So basically, we want to check our solution. Okay, so we got log base 6 of 5x minus 4. Let's plug in 8. Right, a little bit better. Okay, so log base 6 of 5 times 8 minus 4. Well, that's going to equal log base 6 of, this is 40 in the inside, so 40 minus 4. Okay, now here, right, this is 36, just subtracting those. And now, right, we got to make sure this equals to 2. Well, we can get a matching base. So again, this is now 6 squared, right, changing 36. And so the bases undo each other, undoes the logarithm. So now we just have 2. And notice we've proven the left side equals the right side, so we're good to go. We've completed this, so indeed, x equals 8 is our solution. Now, you probably won't see any values that don't work on this exam, or on this daily work. I think tomorrow is when you might get your extraneous solutions. But it's always good to check, especially for these nice ones here, where you've got just one variable on one side of the equation. Okay, let's look at the second daily work problem. All right, so the second daily work problem is just like the one we did up above, where we've got an x value inside the logarithm. So again, we want to undo it, right? Put it in exponential form. So to do that, you exponentiate. So we're going to choose a base of 2. Make my 2's match. So we've got now log base 2 of x and a log base 2 of, oops, what am I doing? And -3, right? So exponentiate it that way. Here you just have x equal to 2 to the -3rd power, right? This is the same thing as 1 over 2 cubed, or 1/8. Again, you can check. We're going to find that this is equal to the same thing. So if you wanted to plug in this in, right, this is the same thing, is equal, if we wanted to check, x is equal to -3. This is log base 2 of 1 over 8. Let's not write it twice. Let's go 8 to the -3rd. Again, this is just going the other direction to make sure that it works. And this is 2 cubed, -3 up there. Oh, hold on. What did I do wrong here? -3. Oh, this would be the -1st power. right? Because I'm just rewriting this as a non-fraction, right? So this is now 2 cubed to the negative first power. So just to be aware of what's changing, because I don't want to skip too many steps here. If that's 8, then this is 2 cubed, right? So the -1 just hangs around in there. So then you can multiply your exponents or your powers. So this is 2 to the -3rd. Again, this is just -3. So this is good practice, just being able to evaluate these. Again, this is exactly what we did up above for those first couple of examples. So you can refer back to those if you'd like to see. Okay, any questions on this one? All right, let's look at the third daily work problem. All right, so this one's a little bit different. Notice that we still have an x inside the logarithm, but now we have a constant here on the left-hand side. So again, before we can change it to exponential form, we need to get the logarithm by itself, right? I think this was step number 1. Okay, so right here, let's subtract 2 on both sides. So we have log base 2 of -2x. This is equal to 2. So now we need to again change it to a log, the exponent form, right? So we want to have a matching base of 2 because that matches our logarithm here, our base of our logarithm. Okay, that's where that comes in. So when we exponentiate, we get log or 2 raised to the log base 2 of -2x, and oh gosh, I always do that. And this is just 2. Okay, so here this undoes that side, so you get -2x. Here you get 2 squared. I want to skip too many steps, so we'll just go -2x is equal to 4. So x is equal to -2. Again, just division by -2 on left and right side. Okay, well, we got to make sure. Well, does that work, right? Is that equal to 4 when we plug it in? So we want to check. X is equal to -2. Again, start with the left-hand side, right? In some classes, it can be written as LHS, right? Left-hand side. So it means 2 plus log base 2 negative. There are so many 2's in this problem. -2 times -2. Just to be clear, this is where this -2 came from. All right, so this is going to be equal to 2 plus, this is now 4, so log base 2 of +4. So 2 plus, now here again, to evaluate this, get a matching base, so 4 becomes 2 squared. So our log base 2 and our base of 2 for this exponent undoes the logarithm, so now we have 2 plus 2. Again, all these 2's make it a little misleading of what's happening. So let me rewrite it like this. So this is 4, this is 2 squared, and there's the last 2, right? So the log base 2 and 2, they undo each other. So here you are, and sure enough, the right side or the left-hand side equals the right-hand side. And that is what we wanted to show, just to make sure. Again, I don't think you'll get any extraneous solutions in this one, but again, I could be wrong. Alex could give you one that might give you an extraneous one. So that is how you do the third one. Any questions? Okay.
And that part where you know where you crossed out the 2's.
Right here.
Which 2 is it crossing out exactly? Is it
yeah, so question is, right, like what's going on right here? Let's use this color to kind of, all right, so let's take a closer look at what's going on here with this problem. Because yeah, it really is like the process here is skipping a couple steps. So we've got 2, and I'm going to go ahead and make this the second power like that. So is everything okay up to that point? Like
Yeah.
okay. So a property of the logarithm, we can move this 2 on the outside. So you can think of it as log base 2, and then the square on the outside, right? And now a couple different things happen, or different ways you can look at it. One property, the power property, or the power rule property for a logarithm, remember that, here, let me move this down here. Move it like that. I don't know what'll happen. Okay, cool, perfect. Okay, so you can think of this as just being on the outside of the logarithm like that. And then the property is saying, we talked about this on Thursday, that the 2 kind of hops over to the front, right? This is another way to express it. So you've got 2 log base 2 of 2, right? This 2 up top, which I guess I had it written in blue, is now in the front of the logarithm, right? And then this is just 1. Log base 2 of 2 is 1. There's a lot of different ways to kind of reason out like why that works. Again, if you wanted to use change of base, right? Well, what would change of base look like here? Well, this would be log base, let's just do 10 over log base 2, right? Here, these 2 are the same thing, right? So anything divided by itself is 1. So all these properties are kind of like mishmashed together to give you the same results. And notice I skipped all these steps here of doing that by just crossing them out, right? Because they just they undo each other. Good question though. It's good. It's good to see kind of the background of what's going on. There is another way that you can look at this. Let's look at, this is just kind of review. So we'll do, because again, I think logarithms, they look really intimidating just based on, how they're written. I think they look kind of bad. Okay, so if I had like log base 2 of 8, right? If I wanted to simplify this down, right, or evaluate log base 2 of 8, you very well could use a change of base formula, right? You could type in log base 8 over log base 2, right? Type that into your calculator. You're going to find that it's 3, right? But let's look more at the math behind it than just using change of base. Again, change of base works. You're welcome to use that. But think that, oh gosh, think that log base, or 8, let's use this color. 8 is the same thing as 2 times 2 times 2, correct? So this is 2 times 2 times 2. Well, our logarithmic property of multiplication says that this right here is the same thing as log base 2 of 2 plus log base 2. I probably shouldn't use 2 for the inside or for the base because it just looks like a bunch of 2's. Again, this is what happened to all these blue 2's, is you're able to separate them in the inside like so, right? And then now you've got a matching base with your matching exponent base, right? And just like we saw up above, this is going to be 1, so it's 1 plus 1 plus 1. Each of these are equal to 1, and that's equal to 3. So again, it's just a bunch of different ways that you can evaluate your logarithms. I would try to do this sort of thing, and then when it fails, use the change of base formula, right? Again, another way to look at it, if this way was kind of strange, is you've got log base 2, and again, 8 can be written as 2 to the 3rd power. And again, the property is saying that when you have something raised to this power, it hops over the log like a frog, and this becomes 3, oops, log base 2 of 2. Again, and that's just 1, so it undoes the logarithm. Are there any other questions? Right, because that's just 1. So you get 3. Okay, so a bunch of different ways of evaluating these. Just be comfortable with this being able to kind of use the properties of logarithms. So this used one property. This up here uses a different type of property. So they'll all get you the same thing. It's just different ways of evaluating it. Okay, the last daily work problem. Oh, I already worked it. Everyone avert your eyes. Thought I deleted that. Okay, so we're gonna get negative 3.86, but let's see if we can get that. Okay, so here it's a little bit different, right? We've got natural log, right? The method will be the same, but it looks a little bit different. It's 3 natural log of x plus 4 is equal to negative 6. Oops, oops. Negative 6. Okay, so here you want the logarithm by itself. So again, you would do division by 3, right? You want to divide both sides by 3 because you want this logarithm to be by itself, right? Even though it's a natural log, it still applies. So you get natural log of x plus 4 is equal to negative 2, right? Negative 6 divided by 3. Okay, so here, recall that the natural log of some value x is the log of base e of x, right? So when you see natural log, your base is e. So that means that when you write it in exponential form, which is our next step, we need to exponentiate with a base of e. So that means we're going to have a base of e here, a base of e here. So that means we'll have natural log of x plus 4 and negative 2, like so. Okay, so the left-hand side simplifies down to just x plus 4. You can put it in parentheses if you'd like. And then e to the negative 2. Right, well, remember that e is an irrational number, right? If you were to type in e into your calculator, let me use this calculator that gave us so much trouble at the beginning, or gave me trouble. Where are we at here? Right, e is 2.71828188284, and so on and so forth. So what this is saying is do not round in any intermediate computations, which means let's not evaluate e to the negative 2 quite yet, right? Because what we want to do is kind of cut off the loss of significant figures, right? We want to be able to get the most accurate solution, right? So, I mean, we don't have the parentheses anymore, but the last thing we need to do is solve for x. So we subtract 4 on those sides. And so what we end up with is whatever x to the x is equal to e to the negative 2 minus 4. So we need to type this in and see what we get. Okay, so we get our calculator. Again, when you type this in, you want to use some parentheses, right? To kind of, you'll have a starting parenthesis. You'll say this is where, you know, this calculation is going to start. What do we got here? So in this calculator, which is, oh, hold on, this is exponential. So that means I could probably click, let me screw this up just a little bit so we can see it. Negative 2 as an exponent. Is that what I'm wanting? No, I don't like that. I use this button. There might be a different button to use. I don't know why that didn't. Anyway, I use this button on the calculator. I think on Alex you'll be given one, a better one. Anyway, so hit E, right? So you're gonna say E, and that's going to be your base. And then you're going to have negative 2, so 2 negative of that. And then you're going to subtract 4 and close that off. So type that in. Did anyone else get negative 3.865 5. I think we're rounding to 3 decimal places, right? Round to the nearest hundredth. Oh, we're rounding to the second decimal place. So we're actually rounding to the second decimal place. So this is equal to negative 3.86 is what that is equal to. Where are we at here? Right. So again, when typing this in here, depending on what the calculator looks like, Alex will look a little bit different in just the sense of like what the calculator looks like. The one I have on this computer is not very good. I mean, it's a very good calculator, or it's a very good computer, but I don't like the calculator it has, as you can tell by my 2 or 3 minutes of, no, like 10 minutes of figuring out why my answer was wrong. Basically to write out what I typed into the calculator, right? In the calculator, put open parentheses, E caret is what that shape is, or that is what that's called, the caret key, -4, and then drop that parenthesis. And that will give you approximately negative 3.86. Of course, rounding to 2 decimal places. All right, that is the last example. Are there any questions? Or would anybody like to see any other examples? Okay, thank you, you two. Yep, we're done with class. So if you have any questions, you let me know. If not, I'll be back tomorrow.
What's with the caret? Are we going to be using that?
The caret is what the button on the calculator looks like. So notice here, I use the caret key. So on Alex, I think when you type it in, it's already like filled in. But even notice on like other scientific calculators, it's a caret key is what it's called. So let me type it in here. What is it? E to the negative 2. So if I did right, so if I had that on my calculator, man, sorry, like right there, I would push the caret key. There's probably a better way to do this, right? The caret key, pushing that
Yeah.
puts it up top.
Oh, okay.
Yeah, so on your calculator, depending on what it looks like, you'll have to type the caret key. Some scientific calculators, like this up here, has a caret key. This is a pretty common one. I like Texas Instruments over Casios. So if you use a Casio, I haven't used a Casio enough to be efficient at it. Right. So this is just saying if you wanted to type like 2 to the negative 3rd power, right? That's just 2 to the negative 3. So yeah, good question. Yeah, it's just a different key for it. Any other questions?
If you want to do another example, that would be cool if you have time.
Yeah, which one?
Probably the last one.
This one here, with a natural
Yeah.
log. So you could do, let's do one. I guess I didn't explain that would work. If you had something like 2 natural log. Let's not do 1. Let's do an even number like 4. Okay, so if I wanted to evaluate that, again, you want the logarithm by itself, right? So before you can do any sort of solving for x, the first step is division by 2, because you want to get the logarithm by itself here. So divide by 2, and that will give you natural log of 3x minus 1. That is equal to 2. So here we have the step where we want to convert it to exponential form. So basically, this just means that we don't want a log, right? So we don't want to even deal with logarithms. So to undo the logarithm, right, remember that the natural log is log base e of 3x minus 1 equal to 2, right? So, these mean the same thing. It's just a different way of rewriting natural log. So what we need is a base that could undo this logarithm. So this step here, where we undo the logarithm, is called exponentiation. And you can think of it as like dividing on both sides, but what you're doing is getting rid of the logarithm. So you've now got a base of e. Oh, this problem's going to be rough, just based on what I chose. So we've got log base e on both sides, and this is log base e of 3x minus 1. You don't have to change the natural log to e. I just want you to see why we chose e as our base here. Okay, so this undoes the logarithm. So now we've got 3x minus 1 equal to e squared. Again, e squared is just a number, so now we just need to solve for x. So that means addition on both sides to get 3x by itself. So now we've got e squared plus 1. I don't know why I chose this particular thing, because now you divide 3 both sides, right? So that means both left and right. So we have x is equal to whatever e squared plus 1 divided by 3 is. So now you need to plug this into your calculator the best way possible to evaluate it. I chose such a bad problem to type in because you want to trap your values in here. So I'm not sure what Alex will look like, what their calculator. I imagine it'll be better than this thing because this isn't very good. Basically, what you want to do when you type this out, let's use this color here. If you type it into the calculator, it would look something like have parentheses, right? And inside the parentheses, you'll have e caret key 2, right? That's just saying e squared. It may even look more like this in your calculator, plus 1, and then you'll do division by 3. And that will be what x is going to be. Okay, so let's type this in. I'll move it in over here. Again, my calculator just isn't very good for this stuff. So I'll put a parenthesis, because that's my open one. I'm going to use this button. This button says x to the y. So I'm going to have e, because that's going to be my base. So now notice it has e raised to the caret key here, and it's going to be 2. You could put parentheses if you like. Right, so notice now it looks almost like what I have. And then you'll do plus 1, right? Because that's, yeah, what we have here. Close that parenthesis. So notice now it's almost done. And now we divide by 3. And then we'll get 2.796. Let's round to 3 decimal places here, just so we don't have to do any sort of crazy rounding. So 3 decimal places would be 796, and then we look at the 3, and the 3 is low, right? So we wouldn't round up. So it would be 2.796 is what our value for x is. 2.796. Right, we can plug it in, but notice that we're still going to get a positive number underneath the logarithm. So I didn't show the step on the last one, but are there any questions over kind of any of this stuff?
Okay, so you showed us like 3 different ways to do this. Do we have to know and use all 3 ways, or can we just stick to like one that works best for us?
So for this method, there's only one way to do it. It's basically get the logarithm by itself and then use a change of base. So notice that the same method was here, hold on, here as well, right? So I got the logarithm by itself, and then I used a base of 2. to rewrite it like this here. And same up here, still had a log base of 2. For these type of problems, it's being able to go in between exponential and logarithmic. Because notice that I get the logarithm by itself, and then I use a base of 6 on both sides, and that undoes our logarithm. So I would say the one thing to work on, and I don't like to memorize certain things, but what we have here is log base. The book uses b of x is equal to y. The book just wants you to know how to go in between these. And so the logarithmic form of this is, let me go, same colors, would be x to the b to the y power, right? So these mean the same thing. So if I was to give you like log base 3 of x minus 2 equal to, let's not do a number too high, 2, right? To be able to go from this form to that form, right? And so just keeping track of like where each of these variables are going. Personally, I don't like to memorize the form because I think it's a little confusing, right? Because this is where the 3 goes, and then you raise the 2 up to that power. So that's kind of what we were doing on the other ones, but I like to use the property of log base 3 of 3 raised to like the m power, right? So anything that you can match these two base numbers, right, is m, or if you had this idea here, right, where if you again, you're matching these two values, they undo each other because they're inverses, and you have m and n. So that's why for these examples, I don't really use the I guess the memorization tactic. I mean, I still in my head, I think, well, to solve this problem, I would do a log base of 3 here and a log base of 3 there, right? Because I can undo the logarithm here. So then this is x minus 2, and this is 3 squared. Let me, and this was the very first chapter that we worked on this, and as long as you feel kind of comfortable with this idea of going in between logarithm and exponential, these types of problems will be solvable. Because tomorrow we're going to look at another type of problem that uses the same idea. There's just a couple more steps in there. So I would say kind of like look back at the other videos and see, you know, or the book or the notes, and kind of see like how we go in between these two. Again, I like to use the logarithmic form and then use this idea of exponentiation to go in between instead of memorizing them. I think the memorization kind of loses like what's going on. It's how I can see kind of how to go in between them. Let's look at if I wanted to do this. If I had like, oops, if I had, oh gosh, if I had x is equal to base b of y, if I wanted to make this into a logarithmic form, notice now that I would need to match this logarithm or this base with a log base of b. So you would do log base b on this side, log base b on that side. Right, so it's saying that you're basically taking a logarithm on this side and taking a logarithm on this side. And what makes it so special is this base matches that base. And that's how you would just end up with y is equal to log base b of x. And so that's kind of the idea between going in between exponential and logarithmic form, which is what we worked on up here. So I hope that helps. I would say kind of work through some examples and see kind of how you go in between each of the forms. I don't know if you have any other questions or.
If you could scroll down, I was writing that
Oh
down.
yeah, sorry.
Thank you.
Let me add a little more explanation here. and all we'll add is this is going from, oh gosh, this is going from exponential to logarithmic. And if you want, oh gosh, and if you wanted to go the other direction, so log base b, I like to make the base a different color, just because I think it makes it clear, like, the important step of going in between each of these. So in this case, we'll do it in orange. This is going from logarithmic to exponential, right? One of them has a logarithm in it, the other one doesn't. So these two forms are the same idea, it just two different methods. Okay, so in this case, you would use a base of b, right, to match this logarithm. So this is x, and this is b to the y.
Can you scroll up a little bit? I can't see the top of what. There we go. Okay. I was just looking at what you wrote.
Yeah, so it's this was kind of an example with just numbers in it. This is just going in between these two forms, which is that's what I was going to write down there. But this is just an explanation of going from, oops, x equal to b to the y, log base b of x to the y. So this is just going in between those two forms. I can't remember what day. I want to say it was April 20th, I think was the class. But it was a similar explanation of going in between them. Again, you can definitely look at just kind of where the letters or variables are going to kind of help you see going in between them. I like this method, which is why I keep using it, but you can definitely use the kind of matching the letters with where they go.
I know I missed class and I wasn't able to do my daily work. My hours have been crazy. So
Okay, you can still turn them in, like the daily works. I think I've opened them up until the end of class.
okay, thank you.
So
I believe the ones that I missed here recently, that's it, right? It looks to me like I got everything else. So
I think so. Yeah, if you go on there, like I said, I should have, and then you can still work on those, any of the test corrections or anything like